So this video we're going to find loads for horizontal members, which it can be beams, which again is kind of like a wall in that sense, or it can be just slabs and you're trying to find the resultant force. Either way, you do want to pay attention to what your find is actually. And in this example, we're going to do a New Jersey barrier. So if you've called them probably Jersey walls, this is what that is, and it's going to be made of plain stone concrete. So here we have a very beautiful cross section. If I do say so myself, I tried really hard. So we have a cross-sectional view of our wonderful Jersey wall, and we want to find the weight per foot of length. Per foot of length. So we do eventually want to get down to pounds per foot. So we first need to ask ourselves, what do we have? We have obviously the cross section. So we'll have cross section area is what we can find. So that's going to be feet squared. So if we're going to multiply our information about concrete by feet squared to get something that's left in pounds per foot, we're probably looking for pounds per foot cubed. That's what we want to look for. So the table that we're going to find that information in is table 1.2. So again, pounds per foot cubed. So we just have that base value of 144. So what we need to do is find the area of this Jersey wall. So it's a lot of fun trapezoids, and I don't personally have the area formula of a trapezoid off the top of my head memorized. So we're going to try and find some easy things like triangles and rectangles that we can do instead. So let's start off just finding the area of, let's go bottom to top. So our area is equal to, we just have, let's color it as we go along. We've got this rectangle right here. So that is just simply going to be base times height. You know, we'll color code our stuff as well. So the base is 24. Remember, this is inches by 6 inches. It's very important because remember that we wanted area in feet squared. So do remember that we are doing things in inches and we're going to have to convert later on. So that's the area of the rectangle. Next, we're going to want to try and find the area of this trapezoid here. So I'm going to start trying to get this triangle first. And I do know that this is a very symmetric shape. So those are these two triangles here. So let's draw it out. Let's just see what we've got. Over here, we're going to have a triangle who we don't know the base. Let's call that X, and this is 55 degrees. And we do know the height. The height is 12 inches. Okay, so if I want to find X, which we can just draw him, that's X right there. If I want to find X, I know that the tangent of 55 degrees is equal to the opposite, which is 12, over the adjacent, which is X. So X is equal to 8.4 inches. Okay, so I'm going to go do my calculation over here. So we're going to add in, we've got two of these wonderful, wonderful triangles here. So we got two. Triangle is 1/2 times the base. The base is X. It's 8.4 inches. The height, of course, we said was 12 inches. So that's my two of those wonderful triangles there. Next, we're going to have the rectangle that's in here, right? So this rectangle, I have X, and I do know that I have two X's, right? I've got X on each side. So if I want to find this value in here, maybe we call it Z. If I want to find Z, I just need to take 24 and minus 2 of that X value, and X was, of course, 8.4. So my Z value is going to be 7.2 inches. So then we're going to come over here and we're going to add base times height. So the base we just said was 7.2 inches. The height again was 12 inches. So we've got a good decent chunk of it. Next, let's see, we want to find this really skinny dude right here. All right, so we want to find that, and of course his counterpart off on the side. All right, we want to find that guy over there. So we got two more little triangles. Okay, so we'll draw them out, and what do we know about them? So again, we've got the base, we've got height. We don't know either of those. That's a little bit weird. But I do know that this is Z right here, right? That's Z. That's what I found. And we do also have the 4 inches up top. So the base is going to be Z. So we have Z minus 4. That's going to give us the 2 triangles divided by 2, and that's going to give us, I guess we can probably call that a new thing. Let's call this D. Call that little guy D. So D is going to be the whole Z distance minus the 4 at the top, all divided by 2. So D is going to be equal to 1.6 inches. Which is great, and don't forget we've also got that angle right there. That angle is 75 degrees. So same thing. Maybe this time I want to find, let's call him Y. Let's call that height Y. So if I want to find Y, we have the tangent of 75 degrees is equal to the opposite, which is Y, over the adjacent, which is D, so 1.6. So Y is equal to 6.0 inches. So again, this is Y. A little bit fun. So we found all of our little dimensions there. So let's go write it out again. Now we've got the orange triangle here, and orange triangle again, and there's going to be 2 of them. So we've got 2 times 1/2. The base is D, which we said was 1.6 inches, and the height, which is Y, which we said was 6.0 inches. Then, last but not least, we do have, let's do it in, I don't know, purple. We have this guy right here. You have that rectangle. So, then what we're going to add, we have a rectangle, and the base of that rectangle is, don't forget, 4 inches up there at the top, right? So he's going to be 4. Keeping my colors consistent here. We got to add in the base of 4 inches times the height. The height was Y. Y was 6 inches. So we do all of that wonderful math. All of that all together, our area is going to equal 364.8. Remember, this is all in inches. This is inches squared. Again, little bit of a problem because we said feet squared. So kind of need to convert that into feet. So we have 1 foot per every 12 inches, and we need to square that. So that's going to give us 2.53 feet squared. Now that we have the area, we can multiply by our number in our table. So the load is going to be our 2.53 feet squared times our 144 pounds per foot cubed. And our feet squared and our foot cubed is going to kind of cancel out again. And we're going to get that our load is equal to 365 pounds per foot, which is kind of funny that it's also that number right there, but remember we divided by 12 squared, and 144 is 12 squared. So anyway, that was just comically convenient.